Hello, I'm Dr. Guy Kuo. I'm here to tell you about anesthesia circuit filters. Here we have 5 different anesthesia circuit filters. These are the kind of things that are used to protect patients on anesthesia ventilators from both each other and from the ventilator. Because the circuit on a ventilator is replaced, but the internals of the ventilator is not replaced between patients. So we need filters to protect both the machine from the patient and also from cross-contamination from patient to patient. You can't tell exactly what kind of filter it is by just looking at its shape. These two look very similar, but this very cheap filter, which is sometimes supplied with an anesthesia circuit, is probably not a viable filter. In fact, we can't find the spec for this filter at all. If you don't know the actual specification for the filter, don't assume that it actually can do the filtering that you need. I would not use this on a Bunny PAPR. It probably won't protect you. Now, moving on to a ViroMax filter. This is a filter which is specified to have both bacterial and viral reduction capability. This has been tested by the manufacturer and is approved by the FDA. It's known to have a 99.99% viral load reduction capability. So we know this filter works. It's going to reduce the viral loads by 99.99%, which is better than what an N95 mask can do. Why do the anesthesia circuit filters have different shapes? Well, it's not just a matter of the mechanical fit, but they also have different functions. Some of the filters, like this intersurgical HydroGuard Mini, also acts as a HME, or heat and moisture exchange device. And the reason for that is we have these hooked up to patients, and we don't want a ventilator to extract heat or moisture from the patient while we're breathing for them. On the other hand, this ViroMax filter is only a filter. It does protection against bacterial and viral contamination, but does not have an HME function. There are also filters or devices that are not filters but are just simply HMEs, and you have to look out for those, because if you use a device which is only an HME on a Bunny PAPR, you get no protection. So either use a bacterial/viral reduction filter or an HMEF. Now, always check the specification for your filter so that you know that it has the appropriate viral reduction that you're desiring. And also another great characteristic to look at is its flow resistance. You'll find that the filters which are purely filters have a much lower flow resistance. In fact, this ViroMax filter, when you test it at 60 liters per minute, only has a pressure drop of 1.5 centimeters H2O. In contrast, the HydroGuard Mini, which is also a HME, so it's an HMEF, has a flow resistance at that same rate of 2.9 centimeters, so nearly double the resistance to flow. And in a Bunny PAPR, it's really desirable to have less resistance in the filter so that you have better intake of air, better clearance of CO2, and the increased flow also allows you to maintain better positive pressure in your bag. So if you have a choice, go for a filter that has lower flow resistance. 1.5 centimeters at 60 liters per minute is fantastic. We don't flow at that rate, so our effective pressure drop is less than that, but that's a good spec to be looking at. Now, viral filters can be different shapes. Some of them are designed so that one end will go onto the circuit and the other end will only go on to an endotracheal tube. On the other hand, this type of filter has both male and female 22 millimeter adapter ends, and is also able to attach to a endotracheal tube. The physical shape varies from filter to filter. Some filters are smaller. Sometimes with the smaller filters, you have to be cautious about how much flow resistance they would have. And this IsoGuard HEPA Small has a significantly higher flow resistance than the intersurgical HMEF, which is, again, double what the ViroMax filter has. You want the lowest flow. How much of a difference does it make? Well, for a 70 kilogram user in a Bunny PAPR, they're able to get around and do most activities with a HydroGuard Mini at 2.9 centimeters H2O resistance. Take that same user, that same 70 kilogram user, and put them in a Bunny PAPR and use a filter with 30% or 40% more flow resistance. You're dropping the inflow of the Bunny PAPR significantly to the point where a 70 kilogram user may not be able to move very quickly without feeling short of breath or anxious. So I would opt for a filter that is at least 2.9 centimeters H2O flow resistance at 60 liters a minute or less resistance. And if I had a choice, I would go for one that has 1.5 centimeters of resistance. If you're in a facility that does not have the ability to get a lower flow resistance Viro filter and are stuck with something like this that has really marginal flow characteristics, there will also be an STL available in the files soon so that you can put two filters in parallel and effectively get a lower resistance, like on the low resistance filter, even though you have a high resistance filter. Two of them in parallel will drop the flow resistance in half almost. Unfortunately, of course, that means you're using two filters simultaneously, so it may be an issue in terms of supply. Now, in these times of shortages, using up filters in a responsible manner is reasonable. If you look at the specifications by the manufacturers for the usage of these filters in a ventilator circuit, they say about 24 hours of use is safe. And that does make sense because when we put them in a ventilator, we're using them bidirectionally, and we're also keeping the filter element quite humid during the entire time we're using it. Now, the French, during the COVID crisis, have been using these filters for up to 48 hours without problems. And so it's probable that you could use these for 48 hours of runtime without running into an issue. I think it's more likely to be okay in a Bunny PAPR than a ventilator, because a Bunny PAPR runs unidirectionally and does not moisturize the filter. It's a completely different environment in terms of bacterial colonization. So a responsible and reasonable conservative materials approach to using these filters would be to allow them somewhere between 24 to 48 hours of runtime, and there should not be too much difficulty with that unless you grossly soil the filter, or what would be very, very bad would be to get any alcohol into the filter element, because alcohol destroys the electrostatic capability of reducing viral load. Okay, so that gives you your summary of filters. Don't use a cheap one that doesn't have any specifications. Always select one that has full viral reduction capability that has been documented and tested. And if you are forced to use an HMEF, and it's likely that you're going to have HMEFs in your hospital because HMEFs are actually more desirable than plain filters if you're on a ventilator, check their flow resistance characteristics and make sure that the Bunny PAPR can get enough flow for the user with the filters that you have. So if you have a choice, get one that has 1.5 centimeters water resistance at 60 liters a minute. You can go up to 2.9 and still be okay for the average size user. If you have a 100 kilogram user, you're going to want a filter like this. So that's it for filters.